Well, hello there. Welcome back to another session of Virtual Field Trips, Travels, and Destinations. My name is Beth Gaff, and I am the Systems Manager, Technology Trainer, and Robotics Instructor here at the Peabody Public Library. I am so excited about our journey today, traveling through the universe. This is going to be a very, very fun experience. If you haven't had a chance to check out our planetarium field trip, I would highly encourage that you take a look at that as well. But this is going to be exploring a little bit more into the universe and everything that it can offers to us and can do for us. So I'm really, really excited about this. I don't want to waste any more time. So let's get started with traveling the universe.
Well, hello there. Welcome back to another session of Virtual Field Trips, Travels, and Destinations. My name is Beth Gaff, and as I stated in the introduction to our class today, I am with the Peabody Public Library. Today, we are going to be taking a journey into the universe. I am so excited. I have done a couple of different field trips that involve planetariums as well as space. However, I'm hoping that we're going to be able to get into the actual universe and things along those lines. And I thought maybe that we could kind of explore a little bit of this together. Yesterday, while I was researching some of my stuff here, I went into YouTube and I was able to find a pretty cool video um, about the universe. And I'm going to see if I can find it again. I meant to save it, but we all know how that can go sometimes. Oh, here it is. So it's called The Edge of the Universe. And it is 10 minutes long, but I find that it's going to be very informative. So I thought maybe we could take a look at this as soon as this commercial is over.
I'm so excited to announce that.
And I'll start it over for us here. There we go. All right, let's take a look at an epic journey from Earth to the edge of the universe.
13.8 billion years ago, something incredible occurred. The Big Bang. The moment when space and time were born. The beginning of the ever-expanding existence that we call the universe. Everything we can touch, feel, sense, measure, or detect is the universe. From the tiniest particles, to the largest galaxies, to the very existence of space, time, energy, and life. The beginning of the universe is the beginning of everything. In a way, we are a small part of the universe attempting to understand itself as we peer out into the unknown and observe the wonders that it has to offer. We have been able to discover extraordinary things from Earth, but now we must leave our blue planet and explore the farthest reaches of the cosmos. Our journey begins at home, the Earth, a world unlike any other, the only place in the known universe confirmed to host life. Millions upon millions of different species exist upon its dynamic surface, but none have changed its landscape like human beings. From this view, human activity is easy to see. Our buildings, roads, and farming fields will likely be evidence of our existence for hundreds, if not thousands of years to come. But as we drift ever higher, everything that we are, everything that we have created, begins to blur. From up here, it would be difficult to see that we ever existed at all. Our entire history can be traced back to this single blue marble. It is the place where billions of people have lived and died, and where many more billions will be born. This is the world where it all started for us, the cradle of humanity. But now we must leave all of this behind and travel further than any human being has ever traveled before. First, we will pass the Moon, our closest neighbour, and the only other place we have walked apart from Earth. Then we will cross the orbits of the planets as we head towards the emptiness that is interstellar space, the area in between the stars. Our magnificent star that warms our seas, stirs our atmosphere, and gives energy to the growing green plants that provide oxygen for life on Earth slowly becomes just one of billions. Many of the stars so familiar to us in our night sky can now be seen, unaffected by the Earth's atmosphere, like colourful bright pinpricks upon a black canvas. This is just a tiny corner of the Milky Way galaxy. Some of these stars have their own planets orbiting them, known as exoplanets, some of which may have the right conditions for life as we know it. But there is no time for us to stop and explore these alien worlds, because we still have a long way to go, and the Milky Way is unimaginably vast. Enormous clouds of gas and dust, along with hundreds of billions of stars, planets and moons, span an area 100,000 light-years across. And hiding deep within that bright bulge, at the very core of the galaxy, is a monster. A supermassive black hole. Now we can see the sheer scale of the galaxy that we call home. And although it is unimaginably large to us, it is only a droplet within an ocean of galaxies that exist throughout the observable universe. Each of these bright points is another galaxy sprawling with clouds of gas and dust, along with billions of stars and planets. Like the Milky Way, which is now just a faint dot in the distance, most of these galaxies conceal a supermassive black hole at their center, and some of them are even merging together in a dynamic cosmic dance of interacting gravity.
As I'm in the midst of applying for residency right now, wish me luck, Grammarly has again been a lifesaver with my application.
From this spectacular view, you will notice that the cosmos is not evenly populated. Instead, large, empty voids can be seen in between dense clusters that are strung together in a magnificent cosmic web. This is a small part of the observable universe, a single page from a 13.8 billion-year-old story spread out in front of our eyes. So where do we go from here? Will we find an edge to the universe? In order to answer that, we must travel billions of light years back to where our journey began. The reason we have come home is because as far as astronomers can tell, there is no edge to the universe. There is only an edge to the observable universe, which is everything we can see from Earth, an unimaginably large area spanning 93 billion light-years of ever-expanding space. What we have just explored can be seen using powerful telescopes from Earth because we are able to see the light from those objects. But light has a cosmic speed limit, and so beyond the edge of the observable universe is the place where light hasn't had enough time to reach us yet. When a distant galaxy millions of light years away is observed, you are seeing it as it was millions of years ago, not as it is today. So the farther away you look, the farther back in time you are able to see, until eventually you find the earliest light that occurred just a few 100,000 years after the Big Bang. Although not a physical edge, this is the edge of our observable universe. It is the afterglow of the Big Bang called the cosmic microwave background. It is the farthest point in the cosmos we are able to see from Earth. But what we don't know is how much of the entire universe is our observable universe. It could be just a tiny speck of a much larger area. You can imagine it like a spotlight centered on wherever you are standing right now. You can see the edge of your spotlight, but not beyond. It is impossible to know what is outside of our cosmic spotlight. However, scientists assume that it is the same as what we can already see, running under the same laws of physics, and is dominated by trillions of other stars, galaxies, and clusters. The unobservable universe may continue infinitely in all directions for all we know. There are many different theories, but the truth is, it is a mystery that we are still yet to solve. I hope you have enjoyed your journey to the edge of the observable universe. If you did, then please tap the like button.
Okay. Well, that was a very interesting piece. I really enjoyed that. And because we're in here looking at different things that involve the universe, now we have all of these different options on the side over here that also would pertain to the universe. Now, one thing that we could also do here is type in virtual field trips, the universe, and see what kind of, they have 9 of them for homeschooling. Let's see if there's any interactive. Okay, so here's a Mars tour.
T-minus 5, 4, 3, 2, 1. Main engine start, 0. And liftoff of the Atlas V with Curiosity.
Could you imagine?
Hi, I'm Katie, NASA JPL research scientist on the Curiosity mission. Welcome to Mars.
Okay, so they have a learning, move, travel.
All the terrain around you has been created using real data and images from Curiosity. By taking photos with 2 side-by-side cameras, we can reconstruct the terrain in 3D. This photo, taken from the Mars Reconnaissance Orbiter, shows the landing site where you're standing now. It also shows where other parts of the landing system ended up, like the rocket-powered descent stage and the parachute. This photo taken from the
Okay, it's the same. So, yeah, so this is a good one. So you could go to Access Mars with Google.
Some areas are black and white because they were only photographed by Curiosity's lower resolution navigation camera.
Okay. That's pretty cool. All right, so that's an interactive Mars tour. And I just went into a basic virtual field trips search, tour the known universe, digital universe. Nice. It's talking about the stars. Outside view of Earth's transit. It's just amazing to me to see all of the different stuff that involve the universe and the makeup of it. That's pretty neat. More information about the universe. Let's go back to the field trip page. 9 Planets Solar System Tour. So this would be good if you're wanting to know more about the solar system and the planets. Let's see what Scope has. Maybe. It's loading. Solar system scope. Ooh, this is pretty cool. Click the screen to run the model. Oh, okay, so you can visit the switch planet solar system. So we could go to Venus, explore, visit. It's very hot and dense. Thick clouds of sulfuric acid and dust reflect most of the sun's light back to space. Venus is one of the brightest objects in our night sky. What else we got here? So we've got Jupiter. Let's take a look at Saturn. Sixth planet from the sun. Okay. So the rings are of gas, ice crystals, water. So this would be a really good site for if you wanted to explore a little bit more about the planets. And your astrology would probably fall into play with constellations. So that's a really good one too. Then you've got explore through 3D virtual. Here's a 3D virtual. So you could actually look at some of these planets as well. Tour of the moon in 4K. They have a virtual planetarium and so forth. So they've got some space. NASA. So there's all kinds of stuff that you could do while visiting the universe and being a part of the universe. Now, something that I wanted to show you. I have in here a pretty cool, and I thought maybe we could do it together. And then I am also going to include it in your lesson plans and curriculums as well. So let me start this. There we go. So this is Components of the Universe. I got this from Teachers Pay Teachers. It is a free source that I was able to download, so I'm able to share it with you because it is free. So we will be able to describe components of the universe, including stars, nebula, galaxies. So if we click on the telescope, now we start talking about the Big Bang. So let's go into YouTube and take a look at the Big Bang and what exactly they're talking about when they talk about the Big Bang. Let's find one that isn't too terribly long. Trying to find one that's not too terribly long. Stephen Hawking knew what happened before the Big Bang. Let's see what this is.
It's time to focus on what you do best. So go to Wix.com.
After our commercial, of course.
Ask a person who's even slightly interested in science, how did the universe begin? And they'll probably say from the Big Bang. From this event, we have time, space, the internet, and you listening to my voice right now. And did nothing exist before the explosion? Most scientists have no idea what was happening, but not Stephen Hawking. So, Stephen Hawking. I think a figure of this stature doesn't need a separate introduction. Much more interesting is how the scientist reasoned. Shortly before his death, Hawking spoke about the Big Bang in an interview with Neil deGrasse Tyson. His assumptions are based on a theory known as the no-boundary proposal, or the Hartle-Hawking state. It's based on the fact that the universe has no initial boundary conditions in time nor in space. To understand how all this works, imagine that someone pressed the rewind button and time began moving in the opposite direction. The universe that is now expanding would contract until it was the size of a single atom, a cosmological singularity. Inside this extremely small, massive, dense speck of heat and energy, the laws of physics and time, which have been in effect for 14 billion years, cease to function. But what did Hawking think happened before the Big Bang? The scientists said that the events before the Big Bang are simply not defined, because it's impossible to measure what happened during them. Since these events have no observational consequences, we can exclude them from the theory and say that time began with the Big Bang. In other words, according to Hawking's theory, the universe literally didn't exist before the Big Bang. The beginning of the universe can be represented by the South Pole of the Earth as a point where the usual laws of physics hold. There's nothing south of the South Pole, so there was nothing around before the Big Bang, Hawking said. But he's not the only scientist who has thought about the beginning of the universe. There are several serious theories, each with its own pros and cons. But to understand them, first you need to remember one important fact. In our universe, there's much more order than chaos. Imagine a bomb filled with sand. The bomb explodes and the billions and billions of grains of sand contained in it are scattered in different directions. In fact, it should end in a complete mess. However, the sand that represents the matter of our universe instead forms itself into beautiful sandcastles. Where there should be chaos, order is formed. This is roughly what happened at the time of the Big Bang. Why the matter was distributed in this way is still unknown. In fact, there are a lot of mysteries in space. For example, why did the meteorite that destroyed the dinosaurs fall on our planet at that time? What if this happened today, or in 1 trillion years? You can only assume. So, back to the hypotheses. According to one of them, the high level of order in our universe is due to the fact that it appeared after the collapse of the previous universe. In other words, our universe could have been formed as a result of a rapid compression and then the Big Bang. By the way, this may indicate that we are currently living in the first reborn universe, or in the 15th, 1000th, the billionth. After all, the process of compression and explosion can continue indefinitely. This hypothetical model of the appearance of the universe is sometimes called the Big Bounce model, but of course, it isn't without controversy. For example, this idea contradicts Einstein's general theory of relativity, the rules by which gravity works. The physical laws that we know cannot explain why the other universe, having reached the singularity, would have given rise to the Big Bang at all and not remain in this position. Another hypothesis suggests that before the Big Bang, the universe seemed to be asleep. That is, it was a very compact, slowly evolving static space. Imagine a cliff with a boulder on its edge in a state of vibration. Any touch would cause it to fall into the abyss. That is, there would be a Big Bang. But this hypothesis also assumes a high level of order in our universe, and it doesn't explain at all what is the reason for this behavior of matter. However, there is a model that can explain almost everything, and this is the multiverse model. According to it, before the Big Bang, there was a large, expanding space from which our universe and an infinite number of other universes were born. So far, humanity isn't able to detect these other universes, and they in turn could have formed either before or after our own. Perhaps some kind of universe is forming right now while you're watching this video. By the way, do you remember the Hartle-Hawking theory that I mentioned at the beginning? According to this view, the Big Bang created an infinite number of universes. Some of them are similar to ours. There are Earth-like planets and even people on them. Other universes may be slightly different. For example, theoretically, there may be a planet similar to Earth, but the dinosaurs on it are not extinct. Or the opposite, things could be very different without the Earth, perhaps even without stars and galaxies, with different laws of physics. This all sounds like science fiction, but according to the mathematical part of the Hartle-Hawking theory, it's possible. Unfortunately, it's not without problems. If there are an infinite number of universes with infinite variations of the laws of physics, this doesn't help us understand what kind of universe we are in and what its features are. This is the paradox that Hawking had been trying to solve for 20 years and was able to do together with Professor Thomas Hertog using the mathematical arsenal of string theory. I won't burden you with complicated explanations. According to the Hawking-Hertog theory, parallel worlds exist, but the laws of physics in them must be the same as in ours. In other words, our universe is typical, which means that any conclusions about it are true for other universes as well. Based on this data, scientists can get close to studying the Big Bang and what happened before it. And Stephen Hawking understood this perfectly well. For example, the study of so-called neutrinos promises a mass of interesting information. Neutrinos are so elusive that they can fly through a dense lead ball the size of the solar system. Neutrino radiation can tell us what happened a few seconds after the Big Bang. And this isn't the only way. It looks like all we can do is wait, or study physics to help scientists find the answer one day. It may turn out that Stephen Hawking was right. Or maybe there was something before the Big Bang that no one's thought of. Sometimes people come up with the most incredible ideas. For example, what would happen if the Earth shared its orbit with another planet? And if you, like me, enjoy asking the universe questions and looking for scientific answers to them, subscribe to the channel. See you soon.
Okay, well, that was definitely a good explanation of some of the Big Bang that we've heard about so many times before. So I would definitely encourage you to explore that a little bit more and see what is actually out there for you. And this tells you a little bit more about the Big Bang, spaceplace.nasa.gov, Earth, Sun, solar system, the universe. And what is the Big Bang? What is the black hole? What is a planet? So, okay, so which astronomer discovered the Big Bang Theory? Oh, I thought I was going to be able to type in there. Let me go back. I don't know if this gives me answers or not. Did they say Hawking? Not 100% sure. I'd have to rewatch that again, but this would be a very good, I think it's Hawking. Oh, it would have been before that. So this is a really good one for you to do on your own as a project, but I thought we could go through it together a little bit. So this is about galaxies. There are 3 types of galaxies. Click each picture below to learn about each type. Label each type of galaxy and answer the question below.
Hey everybody, Evan here with EvanHorizon.com. In today's video, elliptical galaxies. An elliptical galaxy is one without very much structure.
So this is an elliptical galaxy.
And spiraling arms of their galactic counterpart spiral galaxies. The appearance of elliptical galaxies is sort of a bland one, as they take on a rather featureless ellipsoidal shape, rounded rather than flat. Elliptical galaxies are the most abundant type of galaxy in the universe, and thus can range drastically in size, with some dwarf elliptical galaxies being less than 10% the size of the Milky Way, while others, like M87, are identified as some of the largest galaxies in the universe, with over 10 trillion stars. Most elliptical galaxies are composed of older stars with a very thin interstellar medium, leading to little or no star formation. And because of these facts, these galaxies are dim and often hard to spot. So how do elliptical galaxies come about? Most, if not all of them, are thought to be the result of galactic collisions, in where 2 or more galaxies collide and merge, losing their familiar shape to form one with less structure.
Okay, so that was about the elliptical galaxy, so I believe that would be our first one. Let's see this one.
Hey everybody, Evan here with EvanHorizon.com, and for the third type of galaxy we're going to be discussing in this galactic series, irregular galaxies. An irregular galaxy is, well, irregular. With no definitive shape or structure, these galaxies are often chaotic in appearance, just sort of a randomly organized gathering of stars and gas. In many cases, they are thought to have started out as spiral or elliptical galaxies, but were then gravitationally disrupted by a recent galactic collision or near miss, or by being gravitationally influenced by a larger nearby galaxy. Irregulars are thought to make up 20 to 25% of all galaxies in the universe, and are classified into 3 groups. Irregular 1, consisting of the irregular galaxies with the most structure, closely related to spiral galaxies in that they often have disks and bulges, but without any sort of spiral structure, with a bulge located away from the center. Irregular 2, in where there is very little structure at all. And the third group, the smaller dwarf irregular galaxies. Alright.
So I'm going to let you guys explore that one a little bit more on your own. So let's take a look at the last one here.
Hey everybody, this is Evan with EvanHorizon.com, and in today's video we're going to be discussing spiral galaxies. So, hope you guys enjoy, and I thank you for entering the Event Horizon. A spiral galaxy is one that contains a central bulge surrounded by a rotating flattened disk of young, bright stars in the interstellar medium that separates itself into two or more spiraling arms, thought to be the result of density waves, and where the arms of these galaxies are of areas of greater density, slowing down the rotation of stars in molecular gas and compressing said gas to form new stars. The central bulge of these galaxies, made up of an extremely dense amount of old, dim stars, is thought in most cases to contain a supermassive black hole. And although never directly observed due to the gravitational pull of these phenomena being so strong that not even light can escape, the presence of these black holes can be inferred by detecting their effect on nearby matter, such as stars in the interstellar medium. Spiral galaxies can be classified into two groups, ordinary and barred. Ordinary being the galaxies with arms deriving directly from the central bulge, and barred, the galaxy type making up 2/3 of all spiral galaxies, containing a central bar structure composed of stars that the arms emerge from.
So that's about the spiral galaxy. So, all right. Click the picture below to watch a video describing nebula.
Hey everybody, this is Evan with EvanHorizon.com, and in today's video we're going to be discussing planetary nebula, or nebulae. So, hope you guys enjoy, and I thank you for entering the Event Horizon. So planetary nebulae are the ejected diffuse gas given off at the end of a star's life. In the red giant phase, the star will begin to expand, burning through its remaining fuel, and eventually collapsing, dispersing a shell of gas. The name planetary nebula is actually a misnomer given by William Herschel, who had just recently discovered Uranus and thought the new objects had resembled the gas giant. But the first planetary nebula was actually discovered by Charles Messier, and it was the Dumbbell Nebula. And with that, I'd like to show you some of the more popular planetary nebulae. Kicking it off with the Ring Nebula, the Saturn Nebula, the Stingray Nebula, and NGC 2818. Alrighty guys, so that concludes this video. If you enjoyed, don't forget to subscribe right here.
So that tells you a little bit more about the nebula. Asteroids, meteors, and comets. So obviously those are a huge part of our universe.
Invention.
So after this commercial, we're going to learn a little bit more about what a comet is and what its purpose is and how often do we get the opportunity to see them. I know it isn't very often, I can tell you that.
Hello everyone and welcome to our universe. Today we'll be answering the question, what is a comet? So comets are basically dirty snowballs which orbit the sun. They are generally made of ice, such as water, carbon dioxide, ammonia and methane, and mixed in with a bit of dust. These materials come from a time when the solar system was barely formed. Comets have an icy centre, called the nucleus, and this is surrounded by a large cloud of gas and dust, called the coma. The coma is created as the ice in the nucleus is warmed up by the sun and evaporates. Comets can develop two tails as they travel closer to the sun. The straight tail is the gas tail, and the curved tail is the dust tail. The gas tail is created by the solar wind. This pushes gas away from the comet's coma and pointing it straight back from the sun. The dust from the coma is not affected by the magnetic fields, but is vaporized by the sun's heat, and this forms a curved tail, which follows the comet's orbit. So, I hope that's given you a good insight into what is a comet. And of course, if you'd like to know any more...
Okay, so that is a comet. Let's see about an asteroid. Okay. Where do asteroids come from? They are left over from formations in our galaxy. What is a meteorite? So this takes you to meteors and showers. This is pretty cool. And again, I'm going to include this in our teachings or in your lesson plans when I submit this. So let's see what this is.
We know of many stars in the cosmos that are categorized into many forms. You may know some stars as neutron
So this
stars,
tells you a little
white
bit
dwarfs,
more
and red giants.
about the types of stars in the sun, the universe today. So this talks about this is all about the stars.
Like fireflies on a still summer night, they gently dot and illuminate the infinite velveteen sky. Stars, be they millions or billions of years old, are all born in nebulae, clouds of dust and mostly hydrogen gas. Within these stellar nurseries, stars begin life as protostars, or hot cores formed by the collection and collapse of dust and gas. As the protostars become hotter, hydrogen nuclei inside of the cores begin to fuse and create helium. It is this chemical reaction, thermonuclear fusion, that generates a star's heat and energy and causes it to shine. Stars are categorized by a number of characteristics. One of these classifications is by surface temperature. Called spectral classes, these 7 major groups range from the coolest stars, which are designated as M, and up to the hottest stars, which are designated as O. Stars are also classified by the amount of light they emit, or luminosity. Called luminosity classes, these 9 major groups range from the small, less bright white dwarfs to the large and extremely bright hypergiants. But no matter their luminosity or surface temperature, all stars eventually burn through their hydrogen fuel and die out. Less massive stars, such as our Sun, release their stellar material into space, leaving behind a white dwarf surrounded by a planetary nebula. More massive stars instead blast matter into space in a bright supernova, leaving behind an extremely dense body called a neutron star. But the most massive stars, stars that are at least 3 times our Sun's mass, collapse into themselves and create a bottomless well of gravity, a black hole. But from the remnants of stars, heavier elements are cast into the universe, and it is this stardust that formed the seedlings of life itself.
Okay. All right. Well, that's a good reference through National Geographic about stars. So that's a Stars 101. So this would be learning a little bit more about our planets, which we did earlier today. Size of the objects, so planets, stars, galaxies, arranging these in order from largest to smallest. And that concludes our slideshow. So I'll tell you what, I actually learned quite a bit about our universe today. And as far as a lot of our different planets and the stars and the galaxies and the Big Bang, and I mean, we covered a lot in just 40 minutes. So hopefully you'll be able to explore a little bit more. And there you could even do a research topic on Stephen Hawking, on the Big Bang Theory, on the galaxies, on the Mars rover that we saw earlier, maybe some of those comets, asteroids, meteors. So there's really a lot of different things that that you could do. So thank you so much for joining me on another version of Virtual Field Trips, Travels, and Destinations. I'm always looking for topics for us to cover. So if you would like to leave me a message or send me an email, I've included that into our class today. It's at the beginning when you first watch the class, or you could leave me a comment below. So thanks again, everyone. I appreciate you. And I will be seeing you next month in our next Virtual Travels and Destinations.